Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to be using function release rules. So let's go ahead and get started. This is HEC ResSim 3.3. I'm in the Watershed setup module. And we're going to go ahead and just start from scratch, build a reservoir, and then use some of these release function rules. So file, new Watershed. Video 3, go ahead and type the name of the watershed here. Then go ahead and select the directory you want the watershed directory to be stored in, units, time zone, and then we'll be good to go. Okay, so I've got my watershed created. I'm going to go ahead and sketch a stream alignment by holding down the control key, single left click, and then continue to hold down the control key, and then let go of the control key, last click, stream 1 is what I'll call that. Now I'll click the computation point tool and hold down control and do a single left click. And then I'll just name it CP1. Zoom in a little bit here. Okay. Now the reservoir tool, hold down control and then let go and let up and then click again without control held down. Reservoir 1. Okay. And let's add one more computation point down here near the bottom. We'll call that CP4. And then the stationing as 0 down here at the bottom. So make sure to draw your structures in, your streams, your reaches, your reservoirs, upstream to downstream. Okay, I'm going to go add a configuration here. Configuration new, and then let's say 1 hour. Apply. Okay. I'm going to go File, Save Watershed, and then we're ready to head over to the Reservoir Network module. Let's bring those projects in, the reservoir, by going Network, New, and we'll just name it Network 1 and base that on our config 1, New. Okay, that comes in. Let's select the reach tool, hold down control, single left click on the upstream junction, let go of control, single left click on the next downstream junction. We'll just accept this reach name as it is. Do the same thing with the downstream reach. Okay. I'm going to select the junction tool and add an inflow to my upstream junction by edit junction properties. Select local inflow, and I'm just going to call it inflow at CP1 with a factor of 1. Apply and OK. Next, I'm going to click on the reservoir tool and right click, edit reservoir properties. Here, I'm going to first rename the dam to just dam. It just looks better that way. And let's define the reservoir pool geometry. I'm going to head over to Excel, copy my data, and then head back, paste that in. The base elevation is 1350. The top elevation is 1500, and that's feet. So I'll go ahead and click Apply, going with linear interpolation. Okay, I'm going to click on the dam here. I'm in the physical tab of the reservoir. So we were on pool. Here's dam. I'm going to go ahead and add a controlled outlet. Okay, I'm going to just paste in some numbers here and click Apply. All right, everything else is fine as default. So next is the operations tab. I'm going to go ahead and click operations new to create an operation set. Okay. We have our 3 default zones here. We'll just stick with the default zones. And I'm going to go ahead and just have a constant top elevation of these zones for the entire year. We'll say 1500 for flood control. For conservation, I'll say 1440. Click apply, and then inactive, I will set at 1350. Apply. All right, next I want to introduce a rule, and this is going to be a release function rule, the title of the exercise. So let's go ahead and right click on any zone. Let's go with the flood control zone. Add a rule, max release variable CFS. So you'll see what that means in a moment. It'll be for the controlled outlet, and then release function is what I want. So I'll click OK. It's going to be a maximum, so I'll select maximum. Linear interpolation is fine, and then it will be based on the date. That's the default, or the first option there. And then I'm going to paste in the maximum releases based on the date. Okay, pasting those in. And what we have is maximum releases ranging from 800 up to about 1200. You can also see that on the plot here. I'm going to change the interpolation this to step, so it's a monthly time step. Okay, and then apply. Now I'm also going to create a rule for minimum release, 500 CFS. It's going to be for the controlled outlet and then release function. That's good. I'll select minimum and then it'll again be based on date. So, okay. And then we'll just type in 500 and then apply. So it's a straight line for the entire year. Next, I'm going to apply these rules to the conservation zone as well. So I'll just right click and then add rule to all zones. Right click, add rule to all zones. There's no rules associated with the inactive zone. So that looks good. All right, let's go ahead and click apply. And next I need to create an alternative. So let's close that. And let me go ahead and save the network. Okay, alternative edit. Now what I want to do is alternative new. I'll just call this alt1 and click OK. For run control, I'm going to say the time step is 1 hour and leave all the other options as default. Select my operation set. The look back period is going to be 1440, and then the initial release will be 800 CFS because that's the maximum. And my time series data, I still need to prepare, but it's going to be a 1000 CFS constant inflow for the entire year. So let's go ahead and prepare that now. I'm going to just go ahead and save this alternative and I close it. Go tools, open up HEC DSS view. I'm going to go ahead and create a file, new data, save it in my Watershed directory. Sure. Okay, it's been created. Now what I'm going to do is come up to tools. No, sorry, data entry, manual. Let me go ahead and just type in some generic data here. So I'll just call this project, location, flow is the parameter. I'm going to make a daily flow. I want this simulation to be a full year. So hourly would be a little overkill. And then this is going to be 1000 CFS as the description there. Okay, next I got to specify the start date. I'll say January 2023. And then this will be for the full year of 2023. And then units will be in CFS. Select automatic generate and type in our 1000 CFS for the value all year. The end date will be December and the final hour. Okay, and generate. Save. No. And let's just peek at the plot. That looks good. Just a constant 1000 CFS for the entire year of 2023. All right, so let's go back to our alternative now and identify that data time series by navigating to the file we just created and then selecting and clicking set path name. Okay, so this populated right in here. And I think we're good to start our simulation. We'll head over to let me save the network first. Okay, I'm going to go to the simulation module and then create a simulation. I'll just call it simulation 1. And then this is for the year 2023. So I'm going to actually start it on the second day of the year. It's going to be Jan 2, and we'll start it at 2400. And then the last day of the year will be 31 December, and the hour will be 2400 hour. Okay, select our alternative and okay. So we are ready to roll here. I'm going to just click the compute Alt-1 button over here. And something failed starting on January 1st. Oh, 2023. Okay, hold on. I think I goofed up my years. The simulation was for, head over to the simulation tab and simulation edit. Okay, I had the wrong year. Okay, I can't change the start date. So let's just create a new simulation. You guys probably all saw that, right? New simulation, I'll call it simulation 2. And then let me paste in the correct dates here. Okay, so I got the dates in. We're using 2023. If this doesn't work, I don't know what will. Let's go ahead and click compute. And it looks like it ran successfully. And then now let's go ahead and check out the plot for the reservoir. And this looks pretty exciting here. We've got a few things to look at here. The top plot is elevation, first time. And then the lower plot is the release from the reservoir, first time. We have the top of the flood control zone, the top of the conservation zone, and then the top of the inactive zone. And then below that, we have in this bold green line. This is the elevation of the water surface in the reservoir pool. We have a constant CFS flow for the entire year. And then this bold line here in green is the release from the reservoir. So a lot of conclusions can be drawn from this reservoir release. First of all, what I see is that the guide curve elevation is matched at the very beginning, 1440, and then not again until June, and then it stays matched for a couple of months, and then it's off again, and it's back on the guide curve again for the last 2.5 months or so. The reason for this increase in water surface elevation and why it's not matching the guide curve is because the inflow is 1000 CFS for for the full year, but the maximum allowable release is only 800 for January. So what that means is it's releasing the maximum amount, which was 800 and 850, but it's accumulating 200 CFS for the entire month of January, and then 150 CFS for the entire month of February. So that adds up. And then when the release is equal to the inflow, which is right here at 1000 CFS, the month of March, that's when the elevation stops rising. Now it's not decreasing either until the month of April, and that's when the release is 1100, but the inflow remains at 1000. One's the integral of the other. It kind of feels like calculus looking at these. So that's how these two plots relate to each other. And notice that the bold green line seems to be going away. Okay, there we go. Okay, let's spice things up here and modify the inflow. So instead of a constant inflow of 1000 CFS, let's make it 1000 CFS for the first 6 months. Then let's drop it down to 600 CFS for the next 4 months, and then back up to 1000. This will be called alternative 2. So we've seen the alternative 1 plot right now. I'm going to go ahead and close this. And then we're going to go back to the reservoir network. And let me go ahead and actually prepare that new inflow in DSS view. So I'm going to navigate over to my file. It's right here. Okay. And it might be easier to just do a duplicate of this one because it's almost what I want. And I have to change, I'll say 600 to 1000 CFS. Okay. So here's my new record. Just click edit, tabular edit. Let me head down to July 1st and I'll change this value to 600. I'm not going to key in 120 or 122 dates, but I'm going to select that record, hold down Control, and then page down until Halloween, and then right click on the records fill, and then repeat fill. So that's basically going to take the first value and then make it the same for all the highlighted values as you see here. Okay, so let's save that. And let's just double check that it looks correct. And it does. So 1000, 600, and then 1000. Okay, so we have the time series data set prepared. Let's go ahead and create a new alternative. So an alternative new, alt 2. Okay. Let's go with 1 hour. Everything else is the same here. Again, the operation set 1 is good. I'm going to use the same look back data as before. And then the time series is going to be the time series we just created, which will be, there it is. And then set path name. Okay. Looks good. So we'll go ahead and save that alternative. And we're good. We'll head over to the simulation module and then add alternative 2 to our simulation by clicking edit, alt 2, okay. And then I'm going to right click, set as active, and then go ahead and compute alternative 2. And hold on a second. Okay, it says we're missing the very first record here. And this is correct, but it's looking in the wrong file. So hold on a second. Let's go Tools, HEC DSS View. This is the file that it's looking for. So let me open up the DSS file that I created that new time series data set for, and then copy it in here. So I'm going to go ahead and open, navigate to this DSS file, select the path name that I want to copy, and then edit copy to, and then move that over to RSS simulation 2. It's going to be in here. So this button should really say copy, but it says open. Yeah, so one record copied. Okay. So let's go back over to this file, and let me just refresh by going view, refresh catalog, and now it should be here. All right. So this is what I want to set in my alternative. Alternative edit, alternative 2, time series. Okay. Let me just navigate here. Bear with me. Okay. I think that solves the problem. Let's go ahead and save and test it. We're still in the simulation tab and compute. Oh, yeah. Okay, so let's go ahead and take a look at the results. Okay, this is definitely different. What we're seeing here now is different shape. The first half looks the same, but the second half looks different because the inflow into the reservoir now drops down to 600 CFS and then back up to 1,000. And it looks like there was no problem with the reservoir elevation. Okay, next I think it'd be fun to add increase our minimum release rule, which is 500, and make it 650 or 700. I'm going to go ahead and actually add um, the minimum and maximum to this bottom plot here. So if I open up this plot and then select max and add it to region 2, which is the bottom plot, click add, and then same with the min limit, add, apply. Okay, what we see here now is that the release is this line here. It gets down to 600, but it never actually goes below 500, which is the minimum that we set constant value for the entire year. Let's go ahead and increase that minimum to 650 and then see how the reservoir operation behaves. And we'll leave everything else the same. Okay, so I'm going to go ahead and head over to the reservoir network and click on the reservoir, edit reservoir properties. I'm going to change this rule. First of all, let's rename it to 650. Then let's change the value to 650. Apply. Okay. I'm going to save the network. And let's just create a whole new alternative for it. So this is going to be Alt 3. Okay. 1 hour time step. Operation set 1. We'll use all the same data for the look back. And then the time series, we've already fought that battle. Here it is. Set path. Oh, hold on. This might be the same problem as before. Okay. I feel better about that. Then save and okay. All right. Let's go ahead and add that alternative 3 to the simulation 2. Here's simulation 2, edit, alternative 3, incoming. So the only thing we changed here is now we have a minimum 650 CFS flow. Let's go ahead and set that to active and compute. All right, let's take a look at what the reservoir operation did for this year. And yes, indeed, it looks like that minimum flow of 650 came into play here. So this is the inflow, and then right here is the reservoir release. The first half of the year looks the same, and it looks like, let's zoom in. Starting July 1st, the reservoir released 650 CFS to honor that minimum release rule for a couple months. And then at a certain point, it just couldn't anymore. And it released 600, which is equal to the inflow. And that's why the elevation remained constant for those 2 months. And then once the inflow increased again, that's this line, up to 1,000, then it looks like for the next couple weeks, the elevation of the water in the reservoir pool increased up to the target of 1440 again. And while that was happening, the release maintained a 650 minimum CFS. So it honored the rule again right here. And at that time, the release needed to match the inflow again, such that the elevation of the reservoir would not exceed the guide curve elevation. What's interesting to me here is how long it took for this flow rate to change from 650 to 600. And I think I know why. I'm going to zoom in. Yep, this curvature sort of gives it away for me. This is based on the maximum outflow capacity of the controlled outlet. So if we look at some numbers, this is August 31. I'm going to go ahead and hit File, Tabulate. Okay, I've got the table fixed up here. What we see is the outflow is 650 up until August 31st at 2 a.m. in the morning, and then it begins to drop down to 600, and it just kind of asymptotes and finally hits 600 at September 3rd at 7 p.m. So the water surface elevation of 1406 is 600, and I believe that corresponds to, if I check out the controlled outlet, then 1406 corresponds to, yeah, 600 CFS release. So that's a different limitation of sorts. So what I want to do is add a limit on the rate of change, both increasing and decreasing, and then see how that would affect this plot of the reservoir operations while leaving all other parameters untouched. So we're going to do one final alternative here for this simulation. So let's head back over to the reservoir network. Go right click, add new rule, max increase. And this is going to be from the controlled outlet, rate of flow, max increase CFS per hour. And this is going to be, let's just call it 5. Okay. So increasing, that's good. We'll say it's 5. We'll just leave it at constant for now. We'll do one more because increasing and decreasing can be different. So add one more. This will be max decrease for the release, 5 CFS per hour. That'll apply to the controlled outlet, and rate of change limit, that's decreasing, and that's 5. Why? Okay, so let's copy that to the conservation zone. And apply. All right, we're ready to create our last alternative here. Alternative new. 1 hour. That's good. Everything's the same. Okay, file, save, and close. Back over to our simulation module. Oops, forgot to save the network. All right, cool. Right click, edit, then we'll add alternative 4. Okay. And then we'll go ahead and run alternative 4. All righty. Let's take a look at those results. Plot and okay, that's interesting. So what really strikes me is what's going on over here. Let me zoom in. Let me open up the table just to confirm. And then let me hide some of the data that I don't need to see here. Okay, so I'm going to zoom in on this area here. I've got the table data as I like it. So we have the elevation of the pool, and then the inflow and the outflow. The inflow is, where are we here? November 9th. So we're probably like right here on the table. So we have a 650 is our minimum outflow, and the inflow is 1,000. And the reservoir elevation in green on the top plot is increasing, and it's approaching 1440. And once it hits 1440, which is true right around 5 p.m. on November 10th, that's when the release from the reservoir increases from its minimum, and it's It probably like to make an instantaneous increase up to 1000 CFS so it can reach the guide curve faster, but it can't. It's only increasing 5 CFS per hour. So that was based on the rule we just added. So that's right here. But the problem is it can't release all of the inflow. So it's yeah, 1000 CFS come in, 675 leave, 1000 CFS come in, and 710 leave or released. So that explains why we're getting the water surface elevation is actually exceeding the 1440 target, not by much, but a little bit. It looks like the release matches the inflow at right here, which is November 13th, at which what would be a peak pool elevation, at least for this domain, at 1442.8. The release continues to increase at 5 CFS per hour until it's at 1150 CFS release. And then it starts coming, that means the elevation starts coming down. And then that continues until November 16th at 10 a.m. And that's when the reservoir release starts coming down from 1150 CFS down to 1000 CFS. Yeah, sure enough. Hold on, let me zoom in. There should be a little bit more. Yeah, there's still a little bit of a rebound. Okay, so too much analysis and too much numbers, but it's just hopefully a good example here to demonstrate how release function rules work as well as the rate of change limits using this different alternatives and simulations here in HEC ResSim.